At this point, we have a good start to our dust, but we need to start working with the shape controls to modify the details and behavior of our simulation. So if we take a look at what this sim looks like right now, you can see that it's a pretty basic overall motion. We're inheriting some velocities and colliding with the building and the monster, but everything kind of moves as one glob of dust. There's really not much swirling happening in here, and all of our velocities are looking pretty linear. Now the main way to control all of this behavior is with the shape settings on the Pyro solver. So if we dive into our DOPNet and go to that Pyro solver, and then click over to the Shape tab, you can see that the only shape feature that's on by default is the dissipation. And looking back at our flipbook, you can see that dissipation in action as our dust slowly fades off over time. But for a dust simulation, where this dust in the real world is made up of lots of settling particles, I wouldn't expect it to be very obvious in the way that it fades off. So in my case, I found that it was much better to completely turn off the dissipation for this shot. That's not to say that you should never use dissipation for dust sims, but if you do, just make sure that you don't obviously see lots of disappearing density, because that can look a bit unnatural. And now after running a new flipbook with that dissipation turned off, you can see we no longer have that sort of artificial disappearing of the dust material. And this is looking a bit more realistic than with it turned on. And now going back to these shape settings, for dust simulations we typically use disturbance and turbulence, and some people also use confinement quite a bit, although I never got very good results with it, so I tend to not use that option. That confinement is used for boosting, swirls, and curliness, so you can feel free to experiment with that if you would like, but usually I can get the look that I'm going for out of the turbulence and disturbance. Shredding and sharpening are typically more used for fire sims, and we don't need to worry about those for dust. And turbulence is typically used to add larger scale features and movement to the simulation. So if we turn that on and then go to the turbulence tab to check out those settings, some of these noise controls should be familiar from the other areas where noise is used in Houdini. This control field here, pointing at density, means that this turbulence noise is only going to be added in the areas where we have density, rather than adding it to the entire simulation area, regardless of whether there's density or not. For the swirl size, this indicates the actual rough size in Houdini units, so if you have a hard time visualizing it, you could add in boxes to help visualize the scales of those swirls. In this case, I've added boxes here of a size of 5, 1, 0.5, and 0.2. And that can help you to see the overall size of the features that you'll be adding to your sim without even simulating it. Although personally, I don't usually use these reference boxes to figure that out, I will often go back to my geometry. In this case, I'll look at the proxies and maybe middle mouse on that to see what the size is. In this case, I can see that this is a little bit over 33 units tall, and that gives me a pretty good idea of what the overall size would need to be based on the scale of these assets. Now, because we typically use turbulence to add some larger features to the motion of that sim, I'm going to go a bit larger than the default for this example. It defaults to this swirl size of 1, similar to this box here. So let's make that a bit bigger. We'll try 3. And you can check the docs to fine-tune the look of the turbulence based on these parameters here. But this turbulence control is of particular importance because this indicates how many octaves of noise are being added into that turbulence. So if we just leave this all the way down at 1, that's only going to add some of those larger scale features, whereas the higher we turn this up, the more layers of sub-detail will be added in. But for now, I'm just going to leave that at the default of 2. And if we turn the turbulence amount up a bit to 0.4, and I've also turned off the camera culling for the moment so that we can see these effects a little bit better, we can check out what that looks like in a new flipbook. And this effect is a little bit exaggerated, but you can see all of these interesting larger scale shapes being added to our sim. Now this is a little bit too heavy and maybe a bit unrealistic, and overall the density is a bit too high here, so as you work on these things, you'll likely find yourself going back and tweaking your visualization density to look a bit better in the viewport. And it is pretty time consuming to balance all of these things, but I'm going to turn that down a bit for our tests. And it is looking like we may want to bring back a bit of that dissipation, but we'll wait to decide on that until we get more of the simulation properties into the right range. Now you can see that this turbulence remains pretty strong throughout the entire shot, and when you're working on these dust shots, it's very common to want stronger influences toward the beginning of the shot that fall off as the shot goes on. So we can use our fit function to do a quick linear animation on some of those parameters. For example, maybe we want the turbulence to remain fairly strong up through frame 1020 perhaps, and then fall off to very, very little turbulence by 1045. So if we go back to the Pyro Solver's Shape tab and set that turbulence amount to the fit function that remaps the current frame from 1020 to 1045 with turbulence values of 0.4 and 0.01. And I'll try decreasing that swirl size a little bit as well, since these features that we're currently seeing are pretty big. And now viewing that flipbook with our ramped turbulence over time, you can see that we have some more active turbulence being applied in those initial frames, and it really falls off and calms down toward the end of this time range here. Now I'm going to turn that turbulence off to experiment with the disturbance a bit, and that disturbance is meant to add detail into the simulation without changing the overall motion. And it does this just by disturbing those velocities by tweaking them with a little bit of noise so that it preserves its existing velocity, but it's just a bit more broken up. And let's go to the Disturbance tab to check out those settings. And this block size refers to the size of the details being added into the velocity. And once again, this is in world space units, so that would match the sizes of these boxes here. In this case, I'm going to try a disturbance size of 0.5. And this cutoff is telling the disturbance to only affect those lower density edges of the smoke. If you want this disturbance to go a little bit deeper into those heavier density values, then you could turn this up. For example, if you turn that up to 1, then that's going to affect all of the areas with a density up to 1. You can use a different reference field instead that's specified under the Bindings tab here, but typically I would just leave that on density. And you have to be a bit careful with the amount of disturbance applied, because if you go pretty high with this, then the simulation can start to look really fuzzy. In this sim, I've set that disturbance to a little bit more than 5, and this just goes to show how easy it is to go overboard with that setting and to destroy your sim or make it too fuzzy overall. Even with setting this to some lower values, like in this case 0.5, it can still be a bit too fuzzy in some more subtle ways. You can see that although this isn't nearly as crazy as that last version, this is still looking too fuzzy on those edges and breaking that thick dust cloud look that we're going for. And now, just like we did with the turbulence, I'm going to use a fit function over the same frame range to ramp down that disturbance amount from 0.2 to 0.01 as a starting point. And I will bring back the turbulence and increase our smoke object quality a bit by lowering that division size for some more detail. And we'll see what this looks like with the disturbance and turbulence together. Now reviewing our new flipbook, things are much improved. It looks like this is still far too dense, and we have a lot of these very round shapes that we need to break up a bit. Some of those shapes will be reduced if we turn our density down. That should also reduce the stepping a little bit, and we can also try increasing maybe an extra octave of turbulence, and we can maybe use some smaller disturbance sizes or push those disturbances a little bit harder. And it can be quite time consuming to balance all of these properties. Dust does tend to be one of the more difficult and time consuming processes in a destruction shot. And you generally do have to run a whole lot of iterations to get these settings dialed in just right. And we're not just limited to the controls and the pyro solver. We can add multiple layers of these disturbances or turbulences, and we can use other microsolvers as well if necessary. And typically, I don't really need to use many other types of microsolvers for a standard dust sim, but it can be particularly helpful to add an extra layer of disturbance so we can stack up multiple disturbance sizes. For example, maybe we want one level of disturbance breaking things up with a size of 0.5, and another level of disturbance breaking things up with a size of 0.2 or 0.1. So if you add in a gas disturbance node, we can wire that in to the velocity update portion of the pyro solver. That's this third input here. And if you want to add multiple microsolvers, you can merge them in and then wire them into that input. In this case, I think we would only maybe need one additional level of disturbance, but if you want to, you could play around with some of the other microsolvers available. For example, it could be interesting to experiment with the gas diffuse DOP, and I don't think we need that for this simulation, but you could experiment with that if you'd like. And of course, you can explore and play around with all of the other options available. Now I'm going to check the disturbance settings on our pyro solver now. We currently have a block size of 0.5, and I'm going to push the amplitude of this a little bit higher at the start of the sim. And let's copy that whole fit function to use that in our new gas disturbance as well. I'll just paste that into the disturbance amount, and I'll try using the same overall amount for now. I'll set the cutoff a bit higher here. Maybe I'll set this to 0.5, and I'll try a block size of 0.2. And I'm going to try emitting a bit less density from our primary volume source. So let's turn the scale down a bit. And now reviewing the flipbook, it looks like these latest tweaks made a big difference. This is starting to look much more interesting and natural. There are still some things that could be improved. It looks like maybe the turbulence is a bit too high. Everything is stirring around a bit too actively for my liking, and it looks like maybe we could use some more gravity perhaps. And we're also going to add in some custom sources for some of the hero emission points. For example, these areas where his hand impacts the building here and where his head impacts the building there could really use some extra emission sources for both some density and velocity, and we'll look at adding those extra sources next.